total distance traveled, I will have to find out how the body actually moves, if there was a turning point. Is it making sense to you? So this is just like, I start from this point, let's say at time t equals to 0, I'm at position 4 meter, let's say this is position 4 meter, and I move forward by 50 meter, let's say this is the positive x direction, I move forward and I get to a point where x equals to 15 meter, then I turn back. Do you understand what I'm saying? And I'm turning back, I turn back at exactly 1 second, and then I turn back and I surpass the initial position I was. Do you understand what I'm saying? So at the end of the day, I'm at point 1.5 meter. Is it clear? And this happened at the time t equals to 2.5 seconds. Is it very clear now? Do you understand this again? Alright. So the total distance I've covered will be the distance from this point to that point, then back here. Is it clear? So at the end of the day, the total distance traveled. So it is obvious now. Total distance covered, total distance traveled. It's going to be what? It's going to be equal to, that will be 15 minus 4, Abi, plus.
Why don't you pay that minus?
The minus 12. We have no business with it. We're just interested. The minus 12 happens at t equal to 4 seconds. We're just interested in from t equal to 0 to t equal to 2.5. Do you get that? So that's going to give us what now, please? 24.5. So that is the total distance traveled. 24.5 meters. Is it making sense to you? Is it clear? If I'm interested in the average speed, in this case, what do you think I need to do? Total distance traveled, 24.5 over total time taken, which is 2.5. Does that make sense to you? If I'm interested in average velocity, that will be what? Displacement over time interval. Is that very clear? So the displacement is going to be what? Displacement is just going to be 4, is it clear? Minus 1.5, or 1.5 minus 4. 1.5 minus 4 divided by total time, that's 2.5. Is it very clear? Which are totally different answers. So that is to tell you that average speed is not the same as average velocity. Whereas instantaneous speed is magnitude of instantaneous velocity. Does that make sense to you? So it is correct to say that speed is magnitude of velocity. I've said it earlier. When you hear speed with no qualification, it means instantaneous. When you hear velocity with no qualification, it means instantaneous velocity. When you hear acceleration with no qualification, it means instantaneous acceleration. Does that make sense to you? Alright, so that's that about that. I hope this is very clear. Is it very clear? Is it clear? Yeah. Okay. Okay, you want to write it?
5 boy. I don't pick up.
So when the velocity is 0, v equals s equals 0. That means we have 3 squared, it has 2, listen up. So minus 12 minus 36 equals 0. Dividing 2 by 3, you're going to have c squared minus 14 minus 12 equals 0. So what do you get this to be? That's going to be 6 and minus 2. You're going to have t equals to 6 seconds, t equals to minus 2 seconds. You cannot have negative time. I'm not interested in negative time. So when the velocity is 0, that means velocity was 0 and t equals to 3 seconds. Is that clear? That's the only answer that you need. But you don't necessarily have to discard. You don't necessarily have to discard it. Of course, we know the only answer that is correct here is 6 seconds. Right? So the next one, B part, says you should find the velocity, the acceleration, and total distance traveled when x equals to 0. So when x equals to 0, that means you have what? You have t minus 6t squared minus 36t minus 4t to be equal to 0. Abi? So what did you get from here?
10 and minus
t is equal to 10. And t is equal to minus 2. So you would expect to get 3 answers. Abi? The calculator is giving you 2. Yeah. So it could be double of that. So So look at something now. For instance, if you do, listen now, if t is equal to 10, that means that t minus 10, have it now, is going to be a factor. Do you understand what I'm saying at all? Of this polynomial. Does it make sense? So we try to divide. It's okay, there's only for what I want to do now. Do you understand what I'm saying? You are solving it.
If there's no means, forget divide.
So you can do the division and see what this is going to give you. Is it clear? So what does it give you when you divide? You need to have, please pay attention, pay attention. And now, c minus 30 equals to 0. It's one of the factors. Part 1. Do you understand what I'm doing?
Yes.
Do you understand? So what will this give you? T in this, that's going to be t squared, t cubed, minus 10 t squared. So you can subtract that. When you subtract, you're going to have this 0. So minus c, that's minus 6t squared plus 10t squared. That's 4t squared minus 36t minus 4t. Then it's going to give you plus 4. That's going to give you 4t squared minus 4t. It's going to give you what now? 4 minus 4t squared. C is going to be plus 4. So our 4 minus 2. That means we have t squared plus 4t plus 4. Which is c plus 2 all squared. You know that? You understand that thing? So that's the idea. So basically, what you have here is the same thing as having c plus 2 all squared into c minus 10 equal to 0. Is that clear? That's why you got those two answers. One of them occurred twice. Is it clear? So the only thing I'm interested in is t equal to 10 seconds. Because you can't deal with negative time. Is it making sense to you? So x equal to 0 at t equal to 10 seconds. So we see that x equal to 0 at t equal to 10 seconds. Is it making sense? 10 seconds is what we're interested in. Alright, so we're interested in the total distance traveled. So obviously now, look at it now. There is a turning point, between that. Do you understand what I'm saying at all? From t equal to 0 to t equal to 10 seconds, there was a turning point of 6 seconds. Is it clear? So you can plot the graph if you like. You can also solve the problem without plotting the graph. It's recommended that you plot the graph. You can solve the problem without plotting the graph. You already know where the turning point is, You can find the position at the turning point, just like we did the other time. It's going to be the initial minus that, then you do the other one minus the one below. Okay, so look at what I'm talking about now. So x equal to 0 and t equal to 10 seconds. So at t equal to 10 seconds, you can also find the acceleration, and the velocity. What are the other things we're going to have to find? We're going to have to find the velocity, the acceleration, and the total distance when x equal to 0. So when x equal to 0, you can find the velocity. V is equal to the x dt at that time. So our v is this. That's going to be equal to 3 into 10, is that clear? Minus 12 into 10. I'm using this expression. This is v, 10 minus 36. What does this give us? Yeah. 1.4.
Supposed to be 10 times 10 squared.
What is it?
3 times 10.
3 times 10 squared.
Okay, 3 times 10 squared. Yeah. 144 meters per second. Then the acceleration. We found that expression as we found it low. We can differentiate this. Acceleration is equal to the v. That is going to be equal to what? Acceleration is the v dt. That will be 60 minus 12. Is that clear? Then at times equal to 10 seconds. Acceleration of the into 10 minus 12. Acceleration of what? Quiet now. 48 meters per second square. Do you get that? So what's the next thing now? We want to find out the distance covered. Please listen very well. We know that at t equal to 10 seconds, x is equal to 0. Abi? So what do we need to find again? We find at t equal to 6 seconds, which is a turning point between 0 and 10 seconds. Is that clear? So I'll find the position at t equal to 6 seconds. So at t equal to 6 seconds, x will be equal to what? So we're going to have the substitute here, 6 to the power 3 minus 6 into 6 to the power 2 minus 36 into 6, then minus 40. What does this give us? X equal to what? Minus 256. And then at time t equal to 0, what was the position? At t equal to 0, x will equal to, just put t equal to 0 there, minus 40 meters. Does that make sense to you? So we can already tell how the body moves. So at time t equal to 0, we started at minus 40, then it went to minus 256. Do you understand that? Okay. So at time t equal to 6 seconds, it was at minus 256. Is it clear? Then on getting there, it turned back such that at time t equal to 10 seconds, it was at x equal to 0. Is that very clear? So there's only one turning point. Does it make sense to you?
Yes, sir.
Did you get that? So with that, I can get the total distance traveled. The total distance traveled will be, what was the distance traveled from t equal to 0 to t equal to 6 seconds? That will be this, I mean, the difference between this and that. Does that make sense to you at all?
Alright.
Yeah, I can say minus 40 minus 256. What is it? Okay, it's in feet, not meters. Okay. If you just deduct 1 mark, no, make lecturers are not that wicked. If you get your mark, you go back to deduct 1 mark or no mark at all. I'm serious, I'm not that wicked. If you do one way, I know of a lecturer that if you solve the problem, we will go through it. If you make a mistake along the way and your final answer is wrong, you still get all the marks for all the steps. Because maybe your final answer at the point, maybe you did the right lecture. There was an error in your calculator. You just follow through. A lot of lecturers do that actually, but you wouldn't know. So this is, he told us by himself. I'm verified. Okay, so look at this now. So we know the positions at different times. So pay attention now, pay attention. So this means that the body started this way. So let's say we want to do this on our axis. Let's use our x-axis. Okay, and this is time t equal to, this is position x equal to 0. We started at minus 40. So minus 40, let's say it started somewhere around here at minus 40. Then it moved to minus 256. So it's eventually got to minus 256. Is that clear? So the body started at this point, then moved this way. Is it clear? And I'm getting to this point, it went this way. Do you understand what I'm saying? So this is what we want to find out. So this happened at time t equal to 0, t equal to 0 at this point. This happened at t equal to 6, and this happened at t equal to 10. Does that make sense?
So why are you doing that? Why are you doing that?
Yeah, I'm using it to illustrate. That's a lazy way of not drawing the curve. Do you understand what I'm saying? Trying to escape having to draw the curve. Just to illustrate what it means. Alright, so with this, I can get the total distance traveled. Total distance traveled will be equal to this distance from here to here. That will be minus 40 plus 256. Minus 40 plus 256. The point is, we are just taking the distance from here to here. So whatever arithmetic you have done, just get the positive answer. Do you understand what I'm saying? Then this one from here to here, that's going to be 0 minus 256. That's 1 plus 0 plus 56. Abi? So what does that give you?
472.
Eh?
472.
Ah.
Sir.
Okay, 472 feet.
Sir.
Yo.
So, sir, I want to meant like isn't meant not meant to the one at 6 seconds.
No. I just intended in that distance. It doesn't matter how you took it.
So we just take the higher one and the lower one.
Yes.
So even if
Yes.
the negative lot, I just like
Yes, sir, yes.
Is it higher one minus
Because it's distance. Yes, higher one minus 1. Minus 40 is higher than.
So you didn't consider the time at all.
Mark, where
Don't you think it's meant to be like instead of that minus 14 minus
Mark,
it should be minus 2 6 minus
Mark, just do the number
They will do it that way.
still at 6, at
So that you get what? So that you get the negative alpha.
not fight man.
Distance now. Distance is always positive.
We find man.
Do you notice what I did in the first one? Look at the first one we did. 15 minus, 15 minus. Can you see that? For both cases. Because 15 was the highest. Can you see that?
What did you calculate?
Do you understand? Just to get a positive distance between the two of them. That's what matters. Is it clear? Get a positive distance between them. That's what matters. Alright, that's about that. So 11.8. 11.8. The motion of a particle is defined by. So this is quite straightforward. It's similar to 11.6. So you can give it a try. When we So you know something, listen now. This is uniformly accelerated motion. We can solve from the first question that is, you can decide to listen. You can decide to integrate and get your result. I mean, get you're given A, you can use it to get V in terms of T and also X in terms of T. You can integrate. That is fine. You can also do, I mean, in this case, you can use your equations of uniformly accelerated motion directly. You know, either of them will give you the same results. Okay, so look at something now. It means that I know because the acceleration is constant, I know that V should equal to V naught plus AT. Is that clear? Does that make sense? So I've now been given something else. I've been given X when I have a certain V. Is it clear? And I also know that X is equal to X naught plus V naught T plus 1 over 2 AT squared. Can you remember this? And I also know what's the third one? V squared is equal to V naught squared plus 2A into X minus X naught. So I have all these relations. So with this, I might be able to get any one of them that I want to get. So I have when X, listen, X equal to 4 meter, when V equal to 16. So with that, I can do something like this. Listen very well. So I'm going to have this to be V squared is equal to V naught squared. So V is 16 meters per second. So I'm going to have something like this. V is 16 squared is equal to V naught squared plus 2 into acceleration. Acceleration is minus 8. Is that clear? So I'm going to have this to be what? X minus X naught. Does that make sense to you? So our X is 4 meters. So I'm going to have this to be V naught and also X. Again, what is it? Yes, you can use the first one. But the thing is that you are only given V at a certain position. You get that? You are not given the initial velocity. Does it make sense to you? You get that? Okay, so if you make substitution, okay, you can simplify this for that. I think this is based off from the first principle so that you can integrate. Okay? You know, the result you have obtained here is with respect to time t equal to 0. Do you understand what I'm saying here? We integrated by running our initial position from t equal to 0. Is it clear? But in this case, we have not been given parameters from t equal to 0, you have been given from t equal to 4 seconds, and then you are given this as well. So you might want to integrate from the original equations you know. I mean, equations of motion that we started with, that we used to obtain these equations themselves. Okay, I mean the equations v is equal to x dt, a equal to dv dt, and a dx equal to v dv. Can you remember this? Alright, so we can use that directly here. So here, I'm given 4, x equal to 4, where v equal to 16. So I can use this on this relationship. Is it making sense? Why? I would not have to worry about what it was at x equal to 0. Is it making sense? Alright, so when I do that, I can come here and integrate this. I'll just substitute a is equal to minus 8. So minus 8 dx is equal to v dt. So I can integrate this. Is that clear? So I know that when x equal to 4, v was equal to 16. Is that clear? So I want to find x for any v. Is it making sense? Does that make sense? So that's going to give us what now? It's going to give us minus 8x from 4 to x equal to v squared over 2 from 16 to v. So this is going to give us what now? So our minus 8 into x minus 4 is equal to v squared over 2 minus 16 squared over 2. Multiplying 2 by 2, I'm going to have minus 16 into x minus 4 is equal to v squared minus 16 squared. So from there I can make v the subject on the formula. So I can have something like this. So I can say I have v squared is equal to what 16 squared is? 256. 256. So this is going to be equal to 256 when moved to the other side. Minus 16x plus 16 times 4. Do you understand that? Minus 16 times minus 4. Exactly. And plus 16 times 4. What would that give us now? This is going to give us v squared is equal to, so we can put them together. So 56 plus, yeah, what's that? 320. So 320 minus 16x. Exactly. So I have a relationship between them already. So I can now come here and relate x and t. So to do that, I know that, please listen now, I know the v dt, sorry, I know that v is equal